All right, let's dive right in. If you've ever heard names like GPT, BERT, or Llama thrown around and kind of wondered, what really makes them different, then you are in the perfect spot. Today, we're going to crack open the blueprints that power these incredible AI models. So let's get that toolkit open and see what we're working with.
Yeah, this is the big question, isn't it? The world of AI can feel like this confusing soup of acronyms. But what if I told you that underneath all that complexity, most of these powerful models are really just built from a handful of core designs? That's right. It really does come down to three. The best way to think about it is like an AI architect's toolkit. Inside, you've got three main tools, and each one is custom built for a very specific kind of job. If you can understand these three, you'll pretty much understand the whole landscape. So let's get into it. Okay, tool number one, the encoder. I like to call this one the deep reader. Its entire mission, its whole reason for being is to understand. It's built for pure comprehension, to grasp the meaning of a piece of text as deeply as humanly, or I guess as machinely possible. So the magic trick for the encoder is something called bi-directional attention. Now that sounds fancy, but it just means the model doesn't read from left to right like you and I do. Instead, it looks at the entire sentence all at once, the beginning, the middle, the end, everything, to figure out what each word really means in that specific context. It's kind of like how knowing the twist ending of a mystery makes all the clues from the beginning suddenly make sense. So what's this deep reader actually good for? Well, any task that needs that kind of deep understanding. For something like sentiment analysis, it'll read an entire product review to decide, yep, this person is happy, or nope, they're mad. For finding named entities, it scans a whole document to pick out every person, every place, every company. And for what's called extractive Q&A, it can read a huge block of text and find the exact phrase that answers your question. And if you've heard of BERT, you've met an encoder. BERT and its whole family, they're the classic examples of this architecture. They are absolute masters of comprehension. So that's our deep reader. Now, let's grab the second tool from our kit.
Our second tool is the decoder, and I call this one the creative writer. Now, if the encoder was all about understanding text that already exists, the decoder is its polar opposite. It's all about creating brand new text, completely from scratch. The key term here is auto-regressive. Again, sounds complicated, but the idea is actually super simple. The model just writes one word at a time. It predicts the most likely next word based only on the words it's already written. It's constantly looking back at what it just said to figure out what to say next. It's this one word at a time process that lets it generate really fluid and creative language. And that, of course, makes it the perfect tool for any job that involves generation. We're talking about writing an email for you, drafting a story, or being the brains behind the chatbot you're talking to. If new words are being created out of thin air, there's a very good chance a decoder is the one doing the work. And this is a really big deal, so it's important to get this. Almost all of the big, modern large language models that are making headlines, we're talking Meta's Llama, Google's Gemma, they are all built on this decoder-only architecture. At their heart, every single one of them is a super, super sophisticated creative writer. So let's just put it side by side to make it crystal clear. The encoder is the reader. It's bidirectional, it sees the whole context, and its job is to understand. The decoder is the writer. It's auto-regressive, it only sees the past, and its job is to generate. Reader versus writer. That's the core difference. So how in the world do these decoders get so good? Well, it's basically a two-step recipe. First, there's pretraining, where they are just fed a huge portion of the internet, and their only job is to learn the patterns of human language by just predicting the next word, over and over and over again. Then, once they're good at that, they go through instruction tuning. And that's where we teach them how to actually follow our commands and be helpful, which turns them into the powerful assistants we use today. And the results of that training process are, frankly, astounding. These decoder-based models can generate text, summarize articles, translate languages, answer your questions, write computer code, and even reason through really complex problems. It's this incredibly versatile set of skills, and it all stems from that one core creative writer design. But hang on, what if you need a tool that can both understand and generate? Well, for that, we have our third and final tool in the kit, the encoder-decoder hybrid. And let's call this one the master translator. This model is literally the best of both worlds. It's a two-part system. The first half, the encoder, reads your input text and builds that deep contextual understanding.
Then it packages up that understanding and hands it over to the second half, the decoder, which uses it as a blueprint to generate a brand new related piece of text. And this two-step process makes it perfect for any task that's about transformation. Think about it. To translate a sentence from English to Spanish, you first have to deeply understand the English sentence. That's the encoder's job. Then you have to generate a whole new sentence in Spanish. That's the decoder's job. It's the same logic for summarizing an article or fixing your grammar. And your classic models for this are things like T5 and BERT. They are the absolute workhorses of this hybrid architecture, and they excel at these complex sequence-to-sequence tasks. So there we have it. Our three tools, the reader, the writer, and the translator. Now for what is maybe the most important part of all. How do you know which tool to pull out of the toolkit for your project? Because at the end of the day, picking the right blueprint is the key to building anything that actually works with AI. All right, here's your quick and dirty guide. It all comes down to matching the task to the tool. So if your goal is understanding a piece of text that's already there, like with sentiment analysis, you're going to grab the encoder. If you're creating something new from scratch, like a chatbot, you absolutely need the decoder. And for any kind of transformation task, like translation or summarization, the hybrid model is going to be your best friend. In fact, to make it even simpler, you can just ask yourself these three questions. If the answer to number 1 is a big yes, you're probably thinking encoder. If it's all about number 2, you're looking at a decoder. And if it's number 3, well, you're almost certainly in the market for an encoder-decoder hybrid. It really can be that straightforward. So there you have it. We've unpacked the whole AI Architects Toolkit. Now you can actually tell the difference between a BERT, a Llama, and a T5 just by looking at the job they were designed to do. So the only question left is, well, it's the most exciting one. Now that we have the right tools in our hands, what are we going to choose to build? You've got the toolkit. Go make something amazing.